What if your computer could spot your risk for a serious disease way before you even felt sick? It might sound like something out of a sci-fi movie, but it's actually happening right now. Today, we're going to dive deep into the world of data mining and machine learning to see if an algorithm can really predict a health crisis like diabetes.
So here's what we're going to cover. First, we'll get a handle on just how big this diabetes crisis is. Then, we'll look at how we can mine data for hidden clues in patient files. We'll break down a key tool called a decision tree and talk about a common problem called overfitting. After that, we'll see it all work in a real-world study. And finally, we'll ask the big question: what does this mean for the future of medicine?
Okay, let's get started. Before we even talk about the tech solution, we have to understand the sheer scale of the problem we're trying to solve. And believe me, it is staggering.
Let's just start with this number. According to a World Health Organization report that the researchers cited, a whopping 422 million people had diabetes way back in 2014, and that number has only gone up since then. This isn't just some statistic on a page, it's a full-blown global health emergency. And that brings us to the most important point, which the researchers really nailed with this quote. The thing is, early diagnosis is the only way to avoid the worst outcomes. Without it, people can face really awful complications. We're talking heart disease, kidney failure, even blindness. So catching it early, it's not just a good idea, it's everything. So the problem is huge, and the stakes are incredibly high. How on earth can technology help? Well, that brings us to our next part, mining data for clues. This is all about finding those hidden patterns in vast amounts of patient information. Now, the official kind of nerdy term for this whole process is knowledge discovery in databases, or KDD. Really, all it means is finding useful stuff, nuggets of knowledge inside massive collections of data. You can think of it like being a digital detective, sifting through mountains of evidence to find that one crucial clue that cracks the entire case. And what's really important to understand from this is that data mining isn't some magic wand you just wave. It's actually just one step, step 5, in a much bigger, more careful process. You start with a giant mess of raw data. Then you select just the bits you need, you clean it all up, you get it into the right format. Then you do the actual data mining to look for patterns. But you're not done. You have to evaluate those patterns to see if they're actually useful. Only after all that do you get to real, valuable knowledge. Okay, so let's zoom in on one of the most popular tools they use in that data mining step. This is where things get really cool. We're going to talk about the decision tree and how a computer can actually learn to make a diagnosis. I mean, that really is the million-dollar question, right? How can a bunch of code learn to do something that we think of as being so uniquely human, so complex, like spotting a disease? Well, the basic idea is actually surprisingly simple. You're going to love this. It works pretty much just like a game of 20 questions. Seriously, the algorithm just asks a series of simple yes or no questions to narrow down the possibilities until it lands on a final answer. And here's the more, textbook definition, but it's describing exactly what we just talked about. The decision tree builds a sort of flowchart. It starts with the parent node, which asks a big question, like, is the patient's glucose level over 140? The branches are the answers, yes or no. Each answer leads to another node with another question, and so on until you finally hit a leaf node at the very bottom, which gives you the final classification, diabetic or not diabetic. Simple as that. But, of course, it's not always that easy. These models have a pretty serious Achilles heel. Sometimes the problem is that they're too perfect for their own good. And this brings us to a huge challenge in machine learning, the overfitting problem. Okay, so here's the deal. The goal is to find the real underlying pattern, the signal hidden in the data. But with overfitting, the model doesn't actually learn the pattern. It just memorizes the training examples you fed it, including all the random quirks and meaningless noise. It's like a student who memorizes the answers to a test, but has no idea how to solve the problems. It looks like a genius on the practice test, but fails miserably on the real exam when it sees new questions for the first time. So how do you stop the algorithm from basically cheating? Well, the researchers use a few clever tricks. You can set a limit on how deep and complex the tree can get. You can tell it, hey, don't make a final decision unless you have at least, say, 10 examples in a category. Or you can do something called pruning after the tree is built, which is exactly what it sounds like. You just snip off the branches that aren't actually helping make good predictions. All right, enough theory. Let's get back to our original question and see how all this stuff actually performs in a real-world scenario. It's time to see predicting diabetes in action.
The researchers in this study put these algorithms to the test using a very well-known real-world data set. It's called the Pima Indians Diabetes Database. It's an anonymous collection of patient health data that scientists have been using for years to build and test these kinds of predictive models. And here are the results. What's really fascinating here is that not all algorithms are created equal. They tested a few different methods. One, called a support vector machine, got about 65% accuracy. But the top performer in this study was an algorithm called naive Bayes, which basically uses probability to make its guesses. It correctly predicted whether a patient had diabetes over 76% of the time. That's pretty impressive, and it just goes to show that picking the right tool for the job is absolutely critical. So after all of that, what's the big picture? Let's zoom out one last time and think about what this all means for the future of diagnosis. Okay, here are the key things to take away from all this. 1, diabetes is a huge growing problem, and catching it early is everything. 2, data mining gives us incredibly powerful new tools to find patterns we'd never see on our own. 3, cool techniques like decision trees can work, but they have real challenges, like overfitting, that we have to be smart about. And finally, maybe the most important point, these models are amazing aids, but they aren't magic bullets. They're tools, not oracles. And this leaves us with a final, really provocative question to chew on. As these technologies get better and better, we're going to face some pretty tough choices. If an algorithm can eventually diagnose a disease more accurately, more consistently, and earlier than a human doctor, who should we trust? It's a question that we're all going to need to start thinking about as AI keeps reshaping our world and even our own health.